Hello, I'm Kitae. I'm a PhD student at KAIST College of Business. I hope this is the beginning of more opportunities to come in the future. Let me introduce our researchers briefly. Sung-Hyuk Park, Assistant Professor. Minhyung Lee, PhD candidate, are from KAIST College of Business, Seoul, Korea. And Dongwook Shin, Assistant Professor from Hong Kong University of Science and Technology. Our research title is Nonlinear Optimization Model of Advertising Budget Allocation across multiple digital media channels. Now let's start with the research background. In advertising, media planning is a decision process determining how to use time and space of media to achieve objectives, which means marketers should make a decision on the type of media and cost to achieve their advertising objectives. But what many marketers feel painful is that there is no advertising media providing an integrated view on marketing performance. For instance, Facebook ads does not evaluate Google ads performance. Despite its importance, there are lack of researches addressing optimization problem about budget allocation on each marketing channel. So this study aims to propose a data-driven process determining how much budget should be allocated on each advertising medium in digital marketing context. Now let's move to literature review. The first literature measured the impact of display ads on online consumers by analyzing individual level data. And the second article discussed the allocation of advertising budget in the perspective of risk and uncertainty. And third one studies companies face barriers to how to distribute advertising budget in response to business cycles. The first one conducted employee data envelopment analysis for budget allocation and found the increasing trend of advertising inefficiency. And last one suggests budgeting and bidding strategies across two search platforms, maximizing clicks based on game theory. But most prior literatures are limited to solving budget allocation problem on multiple channels, since they are mostly longitudinal studies. Therefore, we developed the budget allocation model that uses the relation between advertising cost and performance on the cross-sectional level. For that, we have to study about advertising response function. The previous literature showed that there is an evidence that relation between advertising cost and performance follows the law of diminishing returns, which means they follow nonlinear curve. Therefore, we assume advertising response curve follows log function. This is an example of curve fitting for each medium. We estimate the alpha and beta using OLS and use this fitted model in the optimization step. And we use a firm level dataset collected from an e-commerce company, which includes 19 digital advertising channels like Google, Facebook, and Instagram. And the period of observation is 1 year. And the key variables are the amount of budget and the number of clicks, purchases, and user acquisitions. We propose this optimization model for multimedia budget allocation problem. This model maximizes conversion under the budget constraints. Specifically, the sum of the budget on each channel should be less than a given amount of total budget, and the budget on one channel cannot exceed the past maximum value of the budget on the channel. We set this because upper limit to avoid extrapolation. But we can adjust the upper limit with the threshold. If we set the threshold value as 0, we fully allow extrapolation. But in that case, we have to carefully use that estimation. Now, I will briefly summarize the budget allocation process as follows: data preprocessing, priority fitting, optimizing budget, and executing. In the step of executing, expertise should review the optimization result and execute. Now, this is the optimization result from the proposed model, which shows more than 40% higher than human practice. When we release the upper limit adjusting threshold, the improvement rate are even more increased. When we set threshold as 2, which means we allow execution by 2 times higher than the post-max budget. In that case, the improvement rate was 47.96%. And when we allow full extrapolation, which means there is no cap on the model, in that case, the improvement rate was 50%. This is very high. And there is another strength of the proposed model, is that it is able to optimize different objectives. We can optimize purchases, clicks, user acquisitions simultaneously. In most cases, this is because in most cases, marketers need to improve multiple KPIs simultaneously. For example, they have to increase purchases and user acquisitions as well. Our model works well in this kind of situation. Let's see. In the second chart, compared to clicks and purchases, the improvement rate of user acquisition is much lower than that of 2, which is only 8%. Likewise, in the first chart, compared to purchases and user acquisitions, clicks improvement rate is much higher. This is because purchase maximization model allocates budget to channels which have higher probability of purchases compared to user acquisitions. To improve 3 objectives simultaneously, instead of using a single model, we can use combination of these 3 models: averaging or weighted averaging. We can use this combination model to improve multiple KPIs simultaneously. It is very useful for marketers. Now, in conclusion, this study contributes to academia as it is the first attempt to design an optimization model for multiple digital marketing channel budget allocation. And one business implication for a marketer is providing a good decision support tool to simulate media planning. And there are several limitations. We need to examine the model with many different data sets collected from various industries such as game, fashion, food, etc. for the robustness check. And we also need to develop more sophisticated advertising response curve to improve optimization result and testing the theory. Thank you for listening. If you have any questions, please send emails to this address. Thank you.